Hello everyone, welcome back to your channel Physics with Oliva. Today we will discuss another problem from ray optics. If you have not subscribed the channel yet, then please subscribe the channel and press the bell icon. Now we will start the problem. At first read the problem. A thin symmetrical double convex lens of refractive index 1.5 is placed between a medium of refractive index 1.4 to the left and another medium of refractive index 1.6 to the right. Then the system behave as. So from the problem we can draw the picture. This is the lens. The refractive index of the lens is 1.5. Okay. And the refractive index of the medium, which is to the left of the lens, the refractive index is 1.4 and the refractive index here is 1.6. Okay, so we will consider this lens as two spherical surface. This is the first spherical surface and this is the second spherical surface. Okay, for the first spherical surface, the refractive index mu1 is 1.4 and the refractive index mu2 is 1.5. And for this is for the first spherical surface. And for this is the second spherical surface. For this, the mu1 is equals to 1.5 and the mu2 is equals to 1.6. We all know the formula for the spherical surface. That is mu2 by v minus mu1 by u is equals to mu2 minus mu1 by r. Right? This is the formula. So we will apply this formula for first spherical surface and the second spherical surface also. Okay, before starting the calculation, we have to take a object distance, right? Here no object distance is mentioned. So we will take the case where the object is placed at infinity. Okay. So that means the rays that are coming, that the incident rays are parallel, right? So suppose we are considering this, that u is equals to minus infinity. That means the incident rays are parallel. Okay. So for the first one, mu2 is equals to 1.5. We don't know. Mu1 is equals to 1.4. U is equals to minus infinity. And this is mu2 minus mu1. That means 1.5 minus 1.4. That is 0.1 divided by r. You can see for this surface the r is positive. How I am telling this? Because for this surface, if we draw the complete sphere, the radius will be like this. So from the sign convention, we all know this. If we are going towards the incident ray, then the sign will be positive, right? So for this is positive radius of curvature. Okay, so this tends to 0 and from here we will get that 1.5 by v is equals to 0.1 by r. From here we will get 15 by v is equals to 1 by r. So from here we get v is equals to 15 r, right? We know after the refraction, first refraction, the image formed is at a distance 15 r. So the image of the first surface will be the object of the second surface for the combination, right? So this is the object distance for the second surface. Okay, this is the object distance for the second surface. So we will write this. Mu2 for the second surface is 1.6 divided by v minus mu1 is 1.5 divided by u. U should be 15 by r, right? Because the object is now like this position. So the distance will be plus u. Okay. Is equals to mu2 minus mu1. That's been 1.6 minus 1.5. 0.1 divided by r. Here the radius will be formed. Suppose we complete the circle like this. the radius will be like this. So opposite to the incident ray. So this should be minus r. So from here we get that 1.6 V is equals to 0.1 minus r plus 1.5 15r. So from here we get minus 1 by r plus this should be 1.6, this should be 1.5 divided by 1.5. Okay, I will write in another position. Here it is very clumsy. So from here we can write 16. We are multiplying this with 10. So this should be 16 by V, 1 by R. This should be minus plus 15 by 15R. So this will be 1 by R minus 1 by R plus 1 by R. This should be equals to 0. So from here we will get that V is equals to infinity, right? So for the total combination, that means for the total lengths, U was minus infinity and V was plus infinity, right? The object distance of the first surface will be the object distance of the lens, and the image distance of the second surface will be the final image of the lens, right? So now here it is option given that for this situation it is the convex lens is behaving as convex lens, concave lens, glass plate, or concave lens. We know only for glass plate or only for glass plate we can see this, that the object distance and the image distance are same. That means if we put the object at infinity, we will observe the image also at infinity. For the convex lens or for the concave lens, we know if the object is put at the infinity, if the incident rays are parallel, then image will form at the focal point, right? But for the glass plate, we know if the object is placed at minus infinity, the image will form at plus infinity, right? So the system is behaving like a glass plate. This will be the correct answer. If you have any doubt regarding the sign convection or the diagram, you can ask in the comment section. I will try to clear your doubts. Thank you everyone. Please like, share and subscribe.